Think about the last thing you did online. Maybe you sent an email or liked a photo. You probably felt like you were totally invisible, right? Well, it turns out a forensic principle that's over a century old says the exact opposite. Today, we're diving into Locard's exchange principle and how it proves that in our digital world, every single contact leaves a trace. So let's start with a classic question, one that's fascinated people forever. Is the perfect crime really possible? I mean, could someone actually commit a crime and leave absolutely nothing behind? No clue, no trace, not a single shred of evidence? Well, believe it or not, a French criminologist named Dr. Edmond Locard answered that question for us more than 100 years ago. He gave us a principle that would become the absolute core of modern forensics. He said, whenever two objects come in contact, there is always a mutual exchange of materials. It sounds so simple, right? But wow, is it a powerful idea? And that one simple idea, it pretty much became the golden rule for anyone trying to solve a crime. So let's really dig into Dr. Locard's work and break down what this principle actually means for us today. So what exactly is Locard's exchange principle? Well, the idea is this. A criminal is always going to leave some tiny trace of themselves at a crime scene. But here's the other side of the coin. They're also going to take a little piece of the crime scene away with them. It's this two-way street, this exchange, that became the bedrock of forensic science. And this gets us to the heart of it. Every contact leaves a trace. Now we're going to see how this idea jumps from the physical world of things like clothing fibers and fingerprints into the invisible realm of digital fingerprints. You see, this mutual exchange is the key. It's not a one-way street. A suspect doesn't just leave things behind, like fingerprints or fibers. They also collect things from the scene. They pick up digital traces, like logs, images, or unique identifiers from the system they touched. It's always a two-way transfer. And that's the crucial point, right there. The fact that they always leave something and always take something, well, that's the trail of breadcrumbs that investigators are trained to follow. Okay. This all makes perfect sense when you're talking about muddy footprints or a strand of hair. But you might be wondering, how on earth does a principle about physical contact apply to the totally invisible world of code, data, and computer networks? Well, it turns out the exchange is just as real online. And the traces are absolutely everywhere. I mean, every single time you interact with a device, you're creating this invisible web of digital evidence. Log files are generated. Your browser history is recorded. Your IP address leaves a trace. We're talking metadata, remnants of deleted files, registry entries, the list goes on and on. The digital world is just covered in these fingerprints. So how do investigators actually put this into practice? Well, for them, a digital crime scene is really just a trail of these digital breadcrumbs, and you can bet Locard's principle is the map they use to follow it. The whole forensic process follows a really clear path. It all kicks off when a cyber attack happens. The attacker has to interact with a system, right? Well, that interaction automatically creates those digital traces we've been talking about. Then it's the investigator's job to carefully collect and preserve those traces, which, if they do it right, will eventually lead them right back to the attacker. Locard's principle is basically the engine that drives this entire process from start to finish. Let's make this super concrete. Imagine a computer hacking scenario. When an attacker tries to log into a system, every single action creates an exchange. They try a password? Boom, that's a login attempt recorded in the event logs. They install some malware? That creates a new file record and changes entries in the registry. Their IP address gets logged by the firewall. See? Every move leaves a mark. And this isn't just for some high-tech movie-style hacking. It applies to much more common crimes, like cyberbullying. Someone creates a fake account? The system logs their device ID and browser fingerprint. They post a nasty picture? Well, the image file itself can contain hidden metadata, and the server is definitely logging their IP address and the exact time it was posted. These traces connect the bully's actions directly back to them. What these examples show us is that Locard's principle isn't just some clever theory. It is the very foundation of digital forensics. You could even say it's a pillar of our modern justice system. So why is it that important? Well, because it establishes a fundamental truth. No digital action is truly traceless. It's the whole basis for how investigators identify and recover evidence from logs and networks, and this is crucial. It provides the scientific backbone that makes digital evidence reliable and trustworthy enough to be used in a court of law. All of this really leads to one single, inescapable conclusion. We've talked about criminals and investigators, but this principle has some pretty big implications for every single one of us. At the end of the day, the takeaway is simple. Locard's principle basically guarantees that every single cybercrime leaves a digital footprint. There's just no such thing as a perfect digital crime. And it's these footprints, these traces left behind from that two-way exchange, that allow investigators to solve the puzzle and prove who was responsible. And that brings us right back to you. Because this principle doesn't just apply to crime scenes, it applies to every little thing we do online. So I'll leave you with this thought. What kind of digital footprint have you left behind today?